In this video, you'll see how you can set up AWS XRay as a data source plugin for Amazon Managed Grafana. With this capability, you can easily visualize service-to-service interactions, proactively capture potential issues and misbehaving tasks, and analyze traces and timeline events in your application. For the purposes of this example, we have already deployed a sample application that's available on GitHub. The application is a pet adoption site that allows end users to search pets by their type and color, select a pet for adoption, and make a payment. We have also configured AWS XRay to trace user request service flows. Let's go to our XRay console now. In XRay, you can use filter expressions to sort incoming traces into groups. In this case, we've created 4 groups that correspond to the actions that visitors to our site can take. Insights and notifications have been enabled for each group. Now let's go to Amazon Managed Grafana to add AWS XRay as a data source. We'll begin by creating a new workspace, which is a logically isolated Grafana server. For the authentication method, we can choose AWS Single Sign-On, or AWS SSO, or Security Assertion Markup Language, or SAML. In this case, we've already enabled AWS SSO, which Amazon Managed Grafana uses to authenticate and manage user access. Let's retain the Service Managed Permissions type, which ensures that the proper IAM roles and policies are enabled. We'll enable all available data sources, which includes AWS XRay. Let's also activate Amazon Simple Notification Service, or Amazon SNS, as the notification channel to add the necessary permissions. Now that the workspace is active, we need to assign users to it. Let's assign a user group. Let's grant admin permissions to the user group so its members can access the data source. Now let's go to the Grafana workspace to configure the AWS XRay data source. We'll sign in with the admin user's AWS SSO credentials. Amazon Managed Grafana auto-discovers the accounts and resources we have available for AWS data sources. We'll select AWS XRay as the service and specify our region. Now that XRay is a provisioned data source, let's go to the settings and make sure the plugin is working. We have the option to make this plugin a default data source. As you can see, our XRay data source is working. Let's configure some dashboard panels so we can explore and visualize data from the pet search application. The query field supports the same filter expressions supported by AWS XRay. Let's render the XRay service map. This is a complex application-wide service map. To better focus on individual flows, we can query the individual groups we created in XRay. For instance, we can run a query on the Make Payment group to see only payment-related flows. The node colors represent the percentage of success, error, fault, and throttled responses. We can select an individual node to view its connections, or edges, each labeled with a success or error percentage and number of transactions per minute. We can drill down on a particular service node by clicking it and selecting a trace filter option. We can now select an individual trace ID to display a timeline for that request. This is useful for pinpointing issues and opportunities for optimization. We can drill into individual segments for more information. And we can select a section of the timeline mini-map to zoom in on a one-time window. In the segment details, we can view any captured stack traces. This stacked trace shows that there's an issue with the permissions policy of the role assigned to the Lambda function, which is preventing the function from updating the adoption status of a pet. To see an example of a different query type, let's run a trace list query. We'll query pet searches where the application took more than 150 milliseconds to respond. The results display in table format. Again, we can click a trace ID to open a side panel with details. In the timeline view, we can see that a table scan is causing the increased latency. We can also run keyword-based queries. Let's query our Make Payment group for traces that contain an edge with errors or faults. As in the service map view, we can see the results in a timeline. From the left panel, we can open our query results in the XRay console or in an XRay service map. From the right panel, we can open the XRay console to view details for the selected trace ID. Let's return to Grafana. We can perform a trace statistics query to aggregate data on our application's performance, including throttle and error counts and average response times. We can narrow down the columns in the dataset that we want to see in the graph. Now let's create a new dashboard that we use to monitor our data. In the first panel, we'll create a service map for the application. Let's name this panel. Next, let's add a panel that graphs the number of total service requests. For this, we'll use a trace statistics query. We can add more panels to graph data such as average response time, slow traces, and failure rates. Amazon Managed Grafana makes it easy to construct the right queries and customize the display properties so that you can create the dashboard you need. You've just seen how to set up AWS XRay as a data source plugin for Amazon Managed Grafana. You can learn more about this topic in the description and links for this video. Thanks for watching. Now it's your turn to try.